So from part B and keeping the derivative on the next page, we need to find the set values of x for which this derivative is greater or equal than 0. So all we can literally write is greater than or equal than 0. And yeah, this is just a case of solving now. So let's have a go at solving this. Okay, so we can split this into two parts. We could say firstly that 22x squared minus 2 is greater or equal to 0, and the second term is greater or equal to 0. Let's write it down. So 22x squared minus 2 greater or equal to 0, or x squared minus 1 to the power of 4 is greater or equal than 0. Oh, so this looks like a difference of two squares, and this one also looks like a difference of two squares in fact. So let's see what we can show here. So because it's greater than 0, firstly we can plus 2 across and divide by 22. This will give us x squared is greater or equal than 2 over 22, which is 1 over 11. And it's just square rooting this. So because the function is greater, this will tell us that if we imagine a derivative curve, then this would mean that the answers are going to be on the outside of the curve. So let me just try and draw a simple sketch. So I'm not going to draw this accurately because we need more points. So suppose the curve is something like this, or something. Because the function is greater or equal than 0, that means we're interested in the outer part. So for example, this range here, any function which is greater than 0. So this means that the solution, if we can square root this one, the results will be outside these intervals. The same applies for here as well. So basically, square rooting this one will give us plus minus 1 over 11. So root 1 over 11, so x here. So this point here would be x equals minus square root of 1 over 11. And this point here would be x equals positive root 1 over 11. Okay, so far this is what the ranges of values can take. Now how about the one over here? Well, first things first, because it's powered by 4, we can assume there's 4 quantities, so we can ignore that. So then therefore we're left with x squared minus 1 greater or equal than 0. And this is a difference of two squares, so therefore x would therefore be, x squared would be greater or equal than 1. Same rules apply, except now that on the left hand side we accept values which is less than minus 1. Square root this one is 1, and on the right side we accept values that are greater than positive 1. However, this interval is these surds are smaller than this one, so in fact the minus 1 and 1 is included in the gx part. So therefore we can say that the final range of solution, because remember minus 1 is somewhere here and plus 1 is somewhere here, so the final solution is going to be x, hold on, let me try and make it in a neater way. Therefore we can say x takes values less than minus square root of 1 over 11, or less than equal, or x takes values greater or equal than positive root 1 over 11. And that's it. Now let's move on to the final part.